Okay, welcome to today's lesson. Before we get started on today's lesson, I'd like to go back and reflect on some previous knowledge that you've acquired and tie it into today's lesson. Okay. As you can see up here, I've got three components up on the screen here. Three components that we've studied in the past. Does anyone recognize the first component?
That's a diode.
Yeah, and this particular diode here is a zener diode. Can anyone recognize this second component?
Voltage regulator.
Exactly, very good. And does anyone recognize this third component that we studied?
Looks like a transistor.
Exactly, it's a bipolar junction transistor. Now, this is a zener diode, and matter of fact, these two devices here are designed for voltage regulation, as you all may recall. This zener diode is designed for low current voltage regulation applications, and this integrated circuit voltage regulator is designed for high current applications. In order to use a zener diode in a high current application, we have to use a bipolar junction transistor with it, and that's what we're going to be investigating today. Is how can we increase the current carrying capacity of a zener diode so that it can regulate higher levels of current. Okay. Well, we can do that by incorporating it with a bipolar junction transistor. Now that you've received pages 123 and 124, I'd like for you to turn to page 124. And you'll see on page 124 there are four circuit configurations for four different voltage regulator circuits. The circuit at the very top of page 124 and the circuit configuration at the very bottom of page 124 we've investigated in the past. Okay. The top figure uses the zener diode by itself, and the lowest most figure uses the integrated circuit voltage regulator that we've talked about in the past. But if you look at the two center configurations, you'll see that those two voltage regulation circuits employ both a zener diode as well as a bipolar junction transistor. We see that same configuration or same combination of components in the schematic right here. This is a schematic diagram of a tape recorder. Okay, and what's shown in the gray area here is a voltage regulator composed of discrete components. You can see the zener diode right there and the bipolar junction transistor that we've talked about in the past. Now that you all have received a copy of the learning goal and the learning objectives for this lesson, let's go over them. Okay? First of all, the name of this lesson is the zener and BJT employed voltage regulators. Our learning goal, as you can see, is to understand the design and operation of voltage regulators which employ both zener diodes and bipolar junction transistors, as well as effectively apply fault analysis to such circuits. In order to fulfill that learning goal, there are four learning objectives. Let's look at those together, starting with learning objective number 1. Based upon information presented and provided by the instructor, as well as introduced in the textbook used for BMT 120, the student will be able to accurately differentiate between a zener diode and bipolar junction transistor voltage regulator circuit, which does not employ output sampling, a zener diode and BJT voltage regulator circuit which employs output sampling, and a zener diode and BJT voltage regulator circuit which employs both output sampling and current limiting in terms of number of BJTs utilized and purpose of each BJT. Moving on to learning objective number 2. Using a lab trainer and the accompanying workbook/lab manual, the student will assess the operation of a zener diode and BJT voltage regulator circuit which does not which does not employ output sampling, as well as a zener diode and BJT voltage regulator circuit, which employs both output sampling and current limiting for various load conditions, as well as input voltage changes, in order to align exactly with the explanations provided in the workbook summaries. Moving on to learning objective number 3. Given schematic diagrams and troubleshooting information for a zener diode and BJT voltage regulator circuit which does not employ output sampling, the student will correctly diagnose all fault conditions they are assigned to examine. And finally, learning objective number 4. Given schematic diagrams and troubleshooting information for a zener diode and BJT voltage regulator circuit which employs output sampling, the student will correctly diagnose all fault conditions they are assigned to examine. You all just received a copy of this rubric, and this is how you'll be graded in this lesson. There's 3 columns, as you can see. The far right column is the high achievement column. The central column is the medium achievement column, and the column to the left is the low achievement column. As you can see here, there are 6 activities associated with this lesson, and each activity is associated with one or more of the learning outcomes that was presented previously. Now, as I indicated previously, the Chapter 9 handout is going to be our primary resource that we'll utilize this morning. I'd like for you to turn to page 231 in that handout, and at the bottom of page 231 is a circuit configuration for a zener diode and bipolar junction transistor voltage regulator that does not employ output sampling. So that will be our first circuit that we'll examine this morning. And I'm going to be drawing that same circuit as you see there at the bottom of page 231. Start out with the zener diode. As you notice, the anode side of that zener diode is connected to ground. The cathode end of that zener diode is connected to the base of our bipolar junction transistor. The collector lead of our bipolar junction transistor is connected to the input side of our voltage regulator. And the emitter lead is connected to the outgoing side of our voltage regulator. Okay. And also incorporated into this configuration is a current limiting resistor connected in line with the zener diode to make it operate correctly. Okay. This is a pretty simplistic circuit both in design and operation. This zener diode will provide a fixed voltage, and I'm just going to make up the voltages for conversational purposes. Let's say this is zener diode is rated at 5.1 volts. As you all know, zener diodes come in different voltage ratings and power ratings as well. This 5 volts is being applied to the base of our bipolar junction transistor, and the output voltage will be 0.7 volts less than the 5.1 volt rating of our zener diode due to the diode drop within the transistor. So we have 5.1 volts at the base minus 0.7 drops due to the base emitter diode, and that leaves us with 4.4 volts of output voltage. That output voltage is the voltage being regulated by this configuration. Now, even though this configuration is simplistic, it lacks good regulation properties. One reason being that as the load current varies on the output side, so that current will pass through the bipolar junction transistor and affect the voltage drop here. So this 0.7 volt drop will vary several tenths of a volt depending on the load current, so the output voltage will fluctuate slightly above and below the 4.4 volt rating.